Hi all, welcome to video 1 of my Raspberry Pi robot project. If you haven't already, I suggest you watch my introductory video which takes you through a high-level build of the project and also gives you a demonstration of what it is we're going to build. In video 1 I'm going to take you through the skills, parts, and tools that you're going to need to really build this project. So let's get into the skills section first. So I do everything from the command line using the Raspbian operating system, and so you're going to need to have at least a familiarity with Linux and operating in a Linux environment. Definitely going to need a basic understanding of the Raspberry Pi and including the GPIO pins and the different configuration of these pins. Some experience with programming in any language, whether it be Python, Java, HTML, doesn't really matter. Any experience will give you enough for what you need for this project. And then lastly, a basic understanding of electronics, because we're going to be connecting up several different boards, and so having an understanding of what it is we're doing and how to troubleshoot it will be important. If this is really your first project in robotics, I would suggest you take a look at this book, Robot Builder's Bonanza, 4th edition. Really good book. This was my first project, and so this helped me kind of get up to speed on different components that I was dealing with. It's not really geared towards the Raspberry Pi in particular, but all the other components gives you a good overview, and if you don't have an electronics background, this will kind of give you a basic understanding of electronics as well. So let's get into the different components of the project that we're going to need to build this out. First one, obviously, is a Raspberry Pi. So I'm using the Raspberry Pi 2 Model B, and like I said, you should be familiar already with the GPIO pins here as I'm pointing to. The other thing that I have, of course, is a micro SD card. I'm using a 16 gigabyte card. You're going to need at least, I would say, an 8 as a minimum. The other part here that I have is a Wi-Fi dongle. I bought one that I made sure was, had all the drivers and so forth were already with the Raspbian OS. So I would recommend that you do a little bit of research and buy one that is going to make it as easy as possible to install it. Next component that we're going to need is a L298N motor controller. I bought this from sanesmart.com. Very inexpensive, about I think less than $10, and this part is going to really control the two motors that we have. And it will connect up obviously to the Raspberry Pi as well. Next key part is a platform of some type. So as you can see, the one that I chose has kind of a treads, two motor design. I chose this really because the tread design like this, instead of 4 independent wheels, works much better on carpet. And so that's why I chose it. But in theory, you could get whatever platform you require. Like I said, if there's 4 motors or 2, it really depends on what kind of surface you're going to be using on for what your purpose of the robot is going to be. So 4-wheel design didn't work very good on carpet, I can say. The wheels really spun a lot, couldn't turn, so I really recommend, if you're going to be using this mostly on carpet, that you look at a track design like this. You'll also notice on my platform I have these metal standoffs. This is really so I can add another layer onto the robot, which we'll get into at a future video. I just bought these metal standoffs at Home Depot. They sell them in the nuts and bolts section. The other component is going to be a Raspberry Pi camera. So this is the one that actually made by Raspberry. This is just the regular camera. They also have a NOR or no infrared. I chose to use just the regular camera. The next component that we're going to need is a pan tilt to mount the camera onto, and so that we can control the camera where we're looking. I bought a very inexpensive pan tilt. It's got two servo motors on it. These are just 5-volt motors, which is what I wanted, so I could power them directly from the Raspberry Pi and not require another battery source. I did end up modifying this, as you can probably see in the video. I'll go through this more in the video that when we're attaching these, of what exactly I did. I bought a very inexpensive pan tilt. I think this was around $20 off of, I think I bought it from robotshop.com. And so, like I said, I had to modify it because it was just jamming up and really wasn't working very well. So we'll go through this in more detail in a further video. Another component is the Bright Pi. So this is LEDs that will allow us to show video and control the robot in the dark. These work very, very well. Bright Pi's, you can buy this from pi-supply.com or just Google Bright Pi. There is assembly required for this. The LEDs come separately in a package, and so you have to solder them onto it. So you will need a soldering iron, solder, and so forth. Very tight on the back of the circuit board, so you have to be very careful when you're soldering. One, to make sure you have the LED in the right way, and two, that you're when you're soldering, you're not soldering across two of the connections, which I did, and it was very easy to do. So take your time on putting this together. How are we powering our project? So there's two parts to it. First one is we're using a LiPro lithium polymer battery, very common, used in drones or other commercially purchased remote controlled vehicles. I've modified this one a little bit to allow me to connect a barrel connector, so I can easily connect it and disconnect it from my project. And I would say you want to be a little bit careful with these batteries. Like any rechargeable battery, when you're charging it, you shouldn't leave it unattended for long periods of time. You want to keep an eye on it. The other thing with the LiPro battery is that you don't want to fully discharge them. I had bought 3 of these in a pack off of Amazon, and I ruined the first 2. Really, I didn't really realize what I was doing, but I fully discharged them, and then they wouldn't charge up thereafter. I ruined one of the cells in here. So this lithium polymer battery is a 7.4 volt, 2 amp. It's got a little bit of kick to it, so be careful when you're working with the positive and negative lead. Don't touch them. I did it accidentally when I was soldering on the barrel connector, and it definitely gave off a good little spark. So this battery is purely powering the 2 motors in the platform that I showed you earlier. So the rest of the project is being powered by power over Ethernet. So the whole idea of this is I didn't want to be constantly recharging a battery to power the Raspberry Pi and all the other components. So I was trying to find a way of doing that. I started looking into some kind of charging docking station, but couldn't really find a project around that. So my next plan B was to use power over Ethernet. So basically this end connects up to the Raspberry Pi, which we'll get into in a future video. It's quite simple. I bought one that already has the right power connector to plug directly into the Raspberry Pi. If you don't find one, you can typically find plug-in converters that will allow you to adapt the common power over Ethernet modules. Pretty straightforward. There's a network cable that goes in between the 2 units. One unit plugs into the wall, a regular wall socket. The other end, as I said, plugs into the Raspberry Pi. I've got about a 25-foot network cable in between, so you can kind of consider the robot is going to be tethered to this. And we have about, I would say in total, we have about 30 feet of extension that the robot can move around in. I've tried it up to a 50-foot cable. I thought maybe there might be some loss of power, but really it was no issue. Even with a 50-foot cable, I could power all the components on this project. You could also, instead of using a Wi-Fi dongle, you could actually connect this up to your network as well. So basically on the end that plugs into the wall, there's also another RJ45 connector there that you would plug into your network drop on the wall. And then on the other end, the end that connects to the Pi, you'll see there's another empty RJ45 connector that you would take a short cable from here and plug it into the RJ45 connector on your Raspberry Pi. So you could do that and basically not use a Wi-Fi dongle. Other thing you're going to need is a assortment of cables. So you can buy these on Amazon, very inexpensive. Two types that I would recommend are, these are probably about 8 inches long. They're female to female and then female to male cables. I would recommend you get a good pack of these because you're going to need it for this project, but really any other project that you're doing with the Raspberry Pi, you're going to need these as well. The other thing you're going to need, I talked about adding another layer to my platform, is some plexiglass. So basically once I get everything mounted on the bottom in the future videos, we're going to install this plexiglass on top, and then we're going to add some more components on top of it. You're also going to require some heat shrink tubing. So this is when there's a few wires that we're going to need to solder together, and then once they're soldered together, you can put black tape on them, but I don't really like that because it eventually will come off. A better way is to use this heat shrink tubing around your solder joints, and it will just protect it and not allow two connections to short together. And again, you can just buy these on Amazon. Also having bought this kit of plastic screws, bolts, and nuts. Very handy for different projects. I use several of them in this project, so again, just bought this on Amazon. And then you're going to need an assortment of tools. I mentioned the soldering iron and solder. Definitely a small, almost like a watch flathead screwdriver. We're going to need this for the L298N motor controller. When we connect up the wires, there's a little screw in there, and that's how we secure the wires to the L289N motor controller. So assortment of screwdrivers is going to come in real handy as well. Okay, so the micro SD card. I really recommend that as you're going through the different videos that you back up the card after each of the videos. I do this quite often in all the projects, and it just allows you that if you get to a point where something's gone wrong and you want to kind of start over again, you can restore that image onto the card and kind of pick up from the previous video, and you don't have to start all over again. It's very easy to do, and if you look at the raspberrypi.org website, there's great instructions depending on what computer you're using, whether it's Linux, Windows, or a Mac computer. Okay, so the next video, or the next part of this video, is going to really getting our Raspberry Pi ready to go for video 2, where we start the configuration. So I'm going to switch over now to recording off my Mac computer. Hi everybody, welcome back. Okay, so now the next step is we're going to configure our Raspberry Pi to make sure it's ready for video 2. First thing that you're going to have to do is to download the Raspbian Jessie operating system. So to do that, simply just go to raspberrypi.org into the download sections for Raspbian. When you get there, you're going to find out there's 2 different flavors of this. First one is a full desktop image, and then the other one is a minimal image based on Debian Jessie. So I highly recommend the minimal image. It is a stripped down version of it. There is some things we're going to have to install to make it work, but its memory usage and everything is very minimal, which is something we're going to need for our project. You can of course download the desktop image, but I think you'll probably find that you're going to have some performance issues. And really it has a lot of stuff that we just don't need for this project. I will be using nothing but command lines, so this image has everything that we need in it. So I'm not going to show you how to download and install it because there's some great instructions on the raspberrypi.org website that show you step by step how to do this. So I'm going to assume that you have gone ahead and done that. So if you do download the light version, there's a couple things that you're going to need to do. So the first one is I found out just kind of by accident that the default keyboard that's in that image when I downloaded it in March 2016 was set up for the UK, which I'm in North America, so the keyboard mapping wasn't correct. Good example of that, when I went to type in a quote, it would actually give me the @ sign. So to resolve that, what you have to do is go into the raspi-config utility, go into international options, and go into the i3, which will change your keyboard layout, and you select it for wherever you happen to be and the type of keyboard that you're using. Once you do that, you're going to have to do a reboot for that to take effect, and that will resolve the first issue. The second one is, the one thing I was using the GUI for in a previous image was to configure my my Wi-Fi. So without a GUI, you have to figure out how to do that through the command line. And it's actually, I found this again on the raspberrypi.org site. There's the URL for it. It's really quite straightforward to do. So what you do is you edit this file located in this directory. The file is called wpa_supplicant.conf, and you add in this text right here. You're going to need to replace the text that's in between the quotes with the information that's unique to your wireless information. So the first one being the SSID, you'll put that in between the quotes, and then your PSK or pre-shared key will go in between the quotes of the next section. The rest you should type in exactly as it says there, and they actually give you an example down below. This article here kind of says that you should auto detect once you make that changes and save the file. However, that didn't work for me. I had to actually do a reboot, and then it came up on my wireless network. Once it's on your wireless network, you should be able to then SSH into your Raspberry Pi, and that's what I've got open here right now. The other thing that I found that was missing in the light version was the RPI update. This is a utility that's used to update the firmware of your Raspberry Pi. So I highly recommend you get that, and it's very straightforward to get it using the apt-get command, install RPI-update. And you would hit enter, and it would take you through the instructions, download and install that. I've already done it, so I won't actually do that. But that was the other thing that's missing out of the light version. Once you do that, I believe you have to reboot for that to work. The next thing that you have to do, whether you're using the full image or the light image, or if you ever restore an image onto your micro SD card, you're going to notice if you use this command df-h that the available memory is only using a fraction of what your card has. So I have a 16 gig card, and you can see it's only using 1.3 gigs, or recognizing 1.3 gigs, and it's 92% in use. So I need to expand that so I'm using the full capacity of the card, because we're going to need that for all the things that we're going to install as part of this. So you go back into the raspi-config utility. It's the first option, number 1, expand file system. Goes through and does something. Basically it says the partition has been resized and you need to reboot. It's going to then ask you, I say finish, would you like to reboot? You say yes, and it's going to go ahead and do a reboot. Okay, our Raspberry Pi has rebooted. We're going to re-type in that command, df-h, and as you can see, I'm now using 15 gigs. So I have a 16 gig card, it's pretty close, and I'm down to 8% usage, so much better. So remember, if you ever restore your image or download a new operating system, take a look at your disk space and make sure you go through that process. So now the last thing we've got to kind of make sure we're doing is that everything is updated on our Raspberry Pi. And it's really, there's lots of documentation out there, but there's 3 commands you're going to want to run, and you're going to want to run these fairly often. The first one is what we downloaded, which was the RPI update. To run that, you just do the sudo RPI update. and if there's a new version, it'll download it, install it, and then you'll have to reboot, and then you'll be at the newest version. So if there is no update, it'll just tell you, and you won't have to do anything. The other command is using apt-get again, and it's the update command. So this is going to download all the new version of the libraries and all that for the Raspbian operating system. Once you run the update, you will then need to run the upgrade using apt-get again, and this will actually then apply all that to your Raspberry. So I recommend it. Basically every time I log into my Raspberry Pi, I pretty much run those 3 commands to make sure I'm running the newest version of everything. I've found many issues resolved by running these commands, so I recommend that you do it often. Once you have that, probably the last thing you'll want to do is just make sure you've set up your password. So the first one, the Pi user, to change the password, you go back into the Raspberry raspi-config, and you go into number 2, change user password. So that's how you would do it. The other one, of course, is the root password. To change that, you just do sudo again, password, root. And this will set up your root password. So I recommend that you change definitely the Pi default password to something, and then you set up a root password. Okay. So we've got our Raspberry Pi kind of at a base configuration. We can SSH to it, and that part is working. So we're in good shape. The next thing you're going to need on your computer that you're using to kind of manage the Pi is a secure FTP program. So I highly recommend FileZilla, which I have here. It's a great app. It works both on the Mac, and there's a Windows version as well. So I highly recommend you get that and use this. And then we're going to use this several times through our project. So we're going to connect to the Raspberry Pi here. Ask me for my password, of course. And it connects you up. So I'm just going to leave that window for a second, and we're going to go to my GitHub site. So this location is github.com /Castlecane / Raspberry Pi -robot. So exactly as it's typed out there on the screen. Once you get there, you're going to find some files, and what we need to do is download these files so that we can then, using the secure FTP file, copy some of them over to our Raspberry Pi. So the first thing, we're going to want to download the zip file. So I'm going to go ahead and do that. Downloading it, downloaded it. I'm just going to move it here over to my desktop, and then so inside of this, there's a number of files here. So first one I'm going to show you are these 2 TIFF files. These are basically the wiring diagram of the Raspberry Pi that we're going to build. You're going to want to have these printed off and in front of you, because I'm going to reference these often. So basically, this is the GPIO pin layout of my Raspberry Pi, and it's showing what is connected to each one of these pins. So as we go through and build this out, we're going to actually connect these up. It also shows you up here the Bright Pi, just for reference, because again, when we're connecting this up, that if you have basically the backside facing towards you, you can see basically the small chip there. The pin to your left is going to be ground, and so on. So I highly recommend that you have this diagram here in front of you. The other one is the L298N connections. So again, this is showing the L298 board that I have and how I've connected up the connections to it. And again, that's going to be referenced in a future video. Now, the important file here, which has a bunch of configurations in it, there's 2 of them actually. It's the config.txt and the www.zip. So I'm going to unzip that, which on my Mac, all I do is double click it, and it's going to give me my www folder. And these are the 2 files that we need to secure FTP over to our Raspberry Pi. So to do that, go back to our FileZilla. You can see the directory that we're in is on the Raspberry Pi is Home Pi, which is where we want to be. So now I'll go over onto my Mac, and I'm going to find the files that I'm going to need to download or secure FTP over to it. So we're going to go into my directory here, and we're going to go into my desktop. And in my desktop, there is the Raspberry Pi Robot Master 2 directory, which is the one I downloaded. And then I've got my www and my config.txt. So I'm going to select those two files, and I'm going to right mouse click on them. Select my two files, right mouse click, and hit update. And that basically, now we can see the files have been moved up to my Raspberry Pi, which is great because we're going to need those in the next video. So basically, at this point, we're in good shape. Our Pi is configured, we've got the configuration files, and we're going to move on to video 2. Video 2 is going to take us through connecting and configuring the motors and the motor controller, the L298N motor controller. So I would recommend that at this point you make a backup of your micro SD card before moving on to video 2.